Okay, in this next video, we're going to start by talking about absolute convergence and conditional convergence. Okay, so a series is absolutely convergent if the absolute value of the series is also convergent. If a sub n is convergent and the absolute value is divergent, which we already saw an example problem earlier in these notes, we call it conditionally convergent. Okay, so let's look at this one. This is an alternating series. So we're going to identify our b sub n. So b sub n is going to be 1 over cube root of n. It's decreasing because it's bottom heavy. And the limit as n goes to infinity of b sub n is equal to 0. Okay, so that's your criteria for alternating series tests. So therefore, this series -1 to the n over cube root of n is convergent by alternating series test. Now, if I take the absolute value of this, so if I take the absolute value of that series, the -1 to the n term goes away. And we're left with the cube root of n. So cube root of n is to the 1/3 power, if you didn't know that. Now, this is going to diverge by p-series test because your exponent, 1/3, is less than 1. Okay, less than or equal to 1. So that means that this is going to be conditionally convergent. Now, you only need to check for conditional convergence pretty much whenever you have an alternating term in there, a negative term. Okay, so just keep that in mind. Okay, the next little thing we're going to talk about is a power series representation of a function. So, power series is 1 over 1 minus x, and it is equal to the series x to the n power. It's a form of a geometric series, and we've already used this form for geometric series. Just remember that it can take this form or it can take this form. The n and 0 have to match, or the n is equal to 1 and n minus 1 power have to match. Okay? Now, let's look at an example real quick. Just going to make one up. Say we have this function right here. 4 over 3 minus x squared. And I want to write it as a power series representation with a series. Okay, when I do this, I'm going to try and look like that format up there. So I'm going to factor out the 4 first. Okay, this number right here always has to be a 1. Okay, so I'm going to divide by 3. I'm going to factor out the 3 on the bottom. Now, when I pull out the 3, I have to do the same thing for this term right here. So I'm going to make it 1/3. Okay? Now, when I go to write this in a power series format, it's going to be 4/3. And I'm going to take whatever this is and I'm going to raise it to the n power, like that. Okay? And if I want to simplify this, I can distribute out the n's and make it 4x to the 2n power and 3 to the n plus 1 power on the bottom. Okay? Because the n would distribute here, and I have a 1 here, and when I multiply, I add exponents. Okay, so that's power series in a nutshell. Radius of convergence and interval of convergence. Okay, so when we're looking for a radius of convergence and interval of convergence, we're going to use ratio test, always. Okay, so our ratio test says that we're going to do the limit as n goes to infinity of a sub n plus 1. So we're going to put an n plus 1 everywhere there's an n. and we're going to multiply by the reciprocal of the original. Okay, now we're going to break it up just a little bit. So we can start canceling stuff. Okay, so the x minus 3 to the n powers cancel. The negative 1 to the n powers cancel. Absolute value of a negative 1 is 1, so I don't have to worry about it. Now, it's important to remember that we're taking the limit as n goes to infinity. So you got n on here, n plus 1. They're the same power, so I'm going to divide the leading coefficient, so it's 1. So all I'm left with is absolute value of x minus 3 is less than 1. Okay? In order for something to converge by ratio test, it has to be less than 1. So that's where that comes from. So your radius of convergence is going to be 1. It's whatever the absolute value is less than. Okay? So when we do interval of convergence, we drop the absolute value signs and we sandwich it in between the two, the plus and the minus. And we solve for x. Okay, so we add 3, so we get that. So this is our possible interval of convergence right there. So when we go to do this, we have to plug back into the original. So for x is equal to 2. I'm going to plug in a 2 right here. And I have to see if the series converges or diverges. So 2 minus 3 is a negative 1 to the n. Like that. Now, a negative 1 to the n times a negative 1 to the n is going to be a negative 1 to the 2n. Anything to an even power is always going to be positive. So you get that. And we know that diverges by p-series test. Okay, and then we're going to do 4x is equal to 4. So we're going to plug in a 4. So 4 minus 3 is 1. One to any power, 1 to the n power is just 1. So I have an alternating harmonic series, okay? And your b sub n would be equal to 1 over n. It's decreasing. The limit as n goes to infinity of b sub n is equal to 0. Therefore, it converges by alternating series test. So I would fill in the equal to sign because it converges. So the interval of convergence actually looks like that. Okay, you can write it in either format right there. So that's how we do interval of convergence and radius of convergence. I do suggest that you probably leave a little more space in this because I'm having a hard time fitting it all in there and I'm writing small. So, okay, the next question, we're going to work it the same exact way. You're going to do the limit as n goes to infinity of a sub n plus 1 over a sub n. So we're going to do x plus 4 to the n plus 1 power over 3 to the n plus 1 times n plus 2. Okay, and we're going to take that and we're going to multiply it by the reciprocal of the bottom. I mean the original. Okay, splitting some stuff up. Okay, so we're going to cancel that, cancel the 3 to the n's. The limit as n goes to infinity of this will go to 1. So we're left with the 1/3 x plus 4 is less than 1. So what we're going to have to do is we're going to have to isolate the absolute value to get our radius of convergence. Okay, so we're going to multiply both sides by 3. Okay, so our radius of convergence is equal to 3. Now, just like we did in the previous problem, we're going to drop the absolute value sign. And then we're going to solve for x by subtracting 4. So that's our possible radius of convergence right there. Okay, so once we get our possible radius of convergence, we're going to take each endpoint. We're going to plug in. So we're going to plug in a -7 right here for x. So -7 plus 4 is a -3 to the n power, all over 3 to the n, times n plus 1. Now, we got to simplify this. And -1 to the n times 3 to the n. 3 to the n's cancel. So you're left with an alternating series. Okay? Trying to skip any steps, your b sub n is equal to 1 over n plus 1. The limit as n goes to infinity of b sub n is equal to 0. This is decreasing. Okay? So this is convergent. So since it's convergent, we write the equal to sign. Okay, now we're going to do for x is equal to a -1. So for x is equal to a -1, I'm going to plug in a -1 right here. So I get 3 to the n over 3 to the n times n plus 1. Cancels, cancels. Okay. We're going to use a comparison test on this, a limit comparison test. So your a sub n is 1 over n plus 1. Your b sub n is 1 over n. So we use this, b sub n diverges by p series. So if we do the limit as n goes to infinity of a sub n over b sub n, you get 1 over n plus 1 times n over 1, which is 1. Okay, it's greater than 0. Therefore, diverges also by limit comparison test. Okay, so your interval of convergence right here is going to be -7 to -1, and it's going to be open parentheses where it's not equal to. Okay, last one. So we're going to start off with a ratio test. The limit as n goes to infinity of a sub n plus 1 times, and we're going to multiply by the reciprocal. Okay, so when we go to simplify this, I'm going to break everything up. Okay, so this becomes 2n plus 2 factorial. So when we go to break that up and cancel it with this 2n factorial, remember a factorial is, say like 6 factorial, 6 times 5 times 4 times 3 times 2 times 1. Okay, so it's going to decrease by 1 until we can cancel something. Okay, so 2 to the n's cancel. X to the 2 n's cancel. And this we don't worry about because we're under absolute value. So if I take the limit as n goes to infinity of this thing, it's always going to be 0, okay, because it's bottom heavy. So 0 is less than 1, correct? Yes. So no matter what this x squared is, okay, it'll always be bottom heavy. So this is your radius of convergence is going to be infinity, and it's your interval of convergence is negative infinity to positive infinity because it's always going to converge. Okay. So that is radius of convergence and interval of convergence in power series. The next video we'll look at Taylor series, Maclaurin series, and we'll be done with series review after that. Hopefully you have a good day. Thanks.